Santham Academy. Welcome to Digital Kaksha. To get updates on new videos, click the subscribe button and the bell icon.
Hello students, today we are going to study the topic combination of resistors. In this topic, basically we will be talking about and discussing about the two types of the combination of resistors. Out of that, the first one is the series combination and the another one is the parallel combination. Let us discuss and understand one by one that when the resistors are given in a particular type of the combination, how we will be getting the equivalent value of their resistance. Let us understand the circuit first. In this circuit, the three resistors of resistances R1, R2 and R3, they are connected end to end. Then here this resistor of resistance R1 is connected to the positive terminal of the battery and the right end of the resistor with resistance R3 is connected to the negative terminal of the battery. That means across the ends of these two resistors, the potential difference which is supplied here with the help of the connection of the battery is V. In this case, the direction of the current, as you all are knowing, it is from the positive to the negative terminal of the battery. Since the resistors are connected end to end, because of that reason, in this particular type of the combination, all the three resistors will be receiving the same value of the current. We know that according to Ohm's law, the three quantities, potential difference, current and the resistance, are related with the formula V is equal to IR. In this combination, the potential difference across the three resistors, it is different, which is shown in the circuit as V1 across R1, V2 for R2 and V3 for R3. The total potential difference of this battery, it is obtained by the sum of these three potential differences. So in this equation we have written as V is equal to V1 plus V2 plus V3. When I will apply Ohm's law formula here, so in place of V it will be written as I into Rs, where Rs is representing the equivalent resistance for the series combination. So IRS is equal to IR1 plus IR2 plus IR3. When I will be taken out common from all these three terms on RHS of this given equation, I on RHS and I on LHS will be cancelled out, and this way we are left with the formula for RS, which is equal to R1 plus R2 plus R3. So the formula for the equivalent resistance in the series combination of a given number of resistors is given by the sum of the resistances of all the resistors. After the series combination, let us understand the parallel combination. In parallel combination, the three resistors with their resistance values R1, R2 and R3 are connected in parallel, or they are connected one below the another. Both the ends of the three resistors are connected respectively with the positive and the negative terminals of the battery. So in this combination, the value of the potential difference across R1, R2 and R3 will be same as that of the potential difference of the battery, which is taken as V in this case. So here by using Ohm's law, we know that V is equal to IR. We have discussed that the potential difference will remain same, but the current which will start from the positive terminal of the battery at this point will be distributed into three parts. That is, let us take the value I1 is the current which will be flowing through the resistor of resistance R1. I2 will be the current flowing through the second resistor, and I3 is the current flowing through the third resistor. So, the total value of the current will be obtained by adding these three currents, which is given in the mathematical form as I is equal to I1 plus I2 plus I3. Now, when I will be using the Ohm's law formula, from this formula I will get the value of I to be equal to V upon R, which is to be substituted in this equation. So, I will get here V upon Rp, where Rp is giving us the idea for the equivalent resistance in parallel combination, will be equal to V upon R1 plus V upon R2 plus V upon R3. Now, from right hand side, when V will be taken out common from all these three terms, here V on LHS and the V on RHS will be cancelled out, and ultimately we are left with the formula, that is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. In order to get and calculate the value of Rp, that is equivalent resistance in the parallel combination of given resistors, after this step we will have to take the reciprocal in order to get the value of Rp. After the derivations of the formula for the equivalent resistance in the series and the parallel combination, let us see the applications of these formulae in several numericals. So, here the question which is given is, in the given circuit diagram, this is the circuit diagram given, where the three resistors of the resistances R1 4 ohms, R2 3 ohms and R3 2 ohms are connected in series combination with the battery whose potential difference is given as 18 volt. It is asked to calculate equivalent resistance, which is denoted as Req, total current denoted as IT, and V1, V2 and V3. We know that in this circuit diagram, V1 will be the potential difference for the resistor R1 resistance. Here it will be V2, and for the resistor of resistance R3, the potential difference will be V3. So, let us understand the way the solution of this question is to be done. First of all, in order to calculate the equivalent resistance, we know that the formula is given as Req is equal to R1 plus R2 plus R3, which will be equal to 4 plus 3 plus 2, that is equal to 9 ohms. So, the first part, that is the value of R equivalent for this circuit, is equal to 9 ohms. Now, using Ohm's law, we know that V is equal to IR. So, the formula for the total current can be written as V upon R equivalent. In the circuit, V, it is the potential difference of the battery, which is given to be equal to 18 volt. So, the value of IT will be calculated as 18 divided by 9. Here, this value of total current will come out to be 2 amperes. Coming to the next part, we have to find out the value of potential difference V1. Here again we will be using the formula by Ohm's law, and Using the formula, we can write V1 to be equal to I into R1. This I will be same as that of the total current because we know that in the series combination, all the resistors receive the same magnitude of the current. So, when V1 is equal to IT into R1, after substitution of the values, I will get here 2 multiplied by 4, that is equal to 8 volt. For V2, the formula will be IT into R2, that is 2 into 3, which is equal to 6 volt. For V3, the formula will be IT into R3, which is equal to 2 into 2, which is equal to 4 volt. So, all the underlined values are the answers for the required quantities which are asked in the numerical. Here one more thing is to be understood, that when we are adding all these 3 values of the potential differences V1, V2 and V3, it should come out to be equal to the given value of potential difference of the battery. So let us check that also in the question. When we will be adding 8, 6 and 4, we will get the answer to be 18 volt, which is only given as the potential difference of this battery. In the next question, the 3 resistors with the resistances R1, R2 and R3 are connected in the parallel combination. The question is given to find the total current, that is IT, equivalent resistance, which is RQ, and I1, I2 and I3 in the given circuit diagram. In this diagram, the 3 resistors in their parallel combination are connected to a battery of potential difference 12 volt. As we know that the direction of the current in the circuit is always from the positive to the negative terminals of the battery. So, this is the total current IT which is drawn from the battery. This IT at this point will be distributed into the 3 parts, as in the parallel combination we know that all the resistors receive the different values of the current. So, let us complete the circuit diagram by taking the current I1 in the resistor R1, I2 in the resistor R2 and current I3 in the resistor R3. Coming to the solution, in which first we are calculating the value of R equivalent of this given circuit. We know that the standard formula for the parallel combination in order to get the equivalent resistance is given as 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. On substituting the values of R1, R2 and R3, I will get here on RHS 1 upon 4 plus 1 upon 6 plus 1 upon 12. In the next step, we will be taking the LCM, which will be 12, and on solving it, the numerator will be obtained as 3 plus 2 plus 1, which is equal to 6 and upon 12. In the simplified form, it can be written as 1 upon 2. Here on LHS, we have 1 upon R equivalent, which is equal to 1 upon 2 in the RHS. From here, on taking the reciprocal on both the sides, I can write that R equivalent is equal to 2 ohms. As we know that Ohm's law is giving us the relationship between the 3 quantities, that is V is equal to IR. So I can write the value of IT to be equal to V upon R equivalent. In the question, the value of V is given as 12 volt. So this value will be obtained as 12 upon 2, which will come out to be equal to 6. So the current, total value of the current is equal to 6 ampere. After that, we have to calculate the value for I1, I2 and I3. So the value of I1 will be equal to V upon R1, that is 12 upon 4, which will come out to be equal to 3 amperes. For I2, the value will be V upon R2, which will be equal to 12 upon 6. It is equal to 2 amperes. The value of I3 will be equal to V upon R3, which is equal to 12 upon 12 is equal to 1 ampere. So this way, the three currents are obtained as 3 ampere, 2 ampere and 1 ampere. To an extent, we can check whether the given values of current are correct or not. How? When we will be adding these three currents, that is 3 plus 2 plus 1, the value will be obtained as 6, which is the value of the total current. In the next question, the circuit which is given, it contains the 4 resistors of the different values. This is the question of the mixed combination of the resistors, where the first 2 resistors are connected in parallel combination. 3 and 4, they are also connected in parallel combination, and through this wire, this complete connection and this combination, it is connected in series combination. So the question is given, find equivalent resistance, that is Req, and total current represented by IT in the given circuit. So in this case, first of all, we will calculate the equivalent resistance for the parallel combination of R1 and R2 using the formula 1 upon R12 is equal to 1 upon R1 plus 1 upon R2. On substitution of the values, we will be getting here 1 upon 3 plus 1 upon 6. After taking the LCM, here 6 will be the LCM and 2 plus 1. Solving it here directly, I can write R12 is equal to 6 upon 3, which will be equal to 2 ohms. Similarly, R3 and R4, they are also connected in the parallel combination. Let us find out their equivalent resistance, which will be given by the formula 1 upon R34 is equal to 1 upon R3 plus 1 upon R4. So 1 upon R34 will be equal to 1 upon 10 plus 1 upon 15. The LCM of 10 and 15, it will be 30, and the numerators will come out to be 3 plus 2, which will give us 5 upon 30, and on taking the reciprocal to get the value of R34, the answer will be equal to 30 upon 5, that is equal to 6 ohms. So here R12 is 2 ohms and R34 is 6 ohms. In the circuit, the two networks are connected in series with each other. So the R equivalent will be obtained by adding these two resistance values. So R equivalent will be equal to R12 plus R34, which is equal to 2 plus 6, that is equal to 8 ohms. In order to get the value of I total, the formula will be IT is equal to V upon R equivalent. In the circuit, the potential difference V of the battery is 10 volt. So, this will be equal to 10 upon the equivalent resistance, that is 8, which will be equal to 5 upon 4 amperes. So, this way, in this question of the mixed combination of the resistors, in the first two steps we have applied the formula and the concept of the parallel combination, and then we have added them R12 and R34 using the concept of series combination. So students, I hope that these concepts of the combination of resistors along with their derivations and the formula you all must have understood. Thank you for watching this video.
Thanks for watching. If you like this video, make sure to like, share and subscribe for more.